and thanks for coming. We're going to be talking about videos and ExoPlayer today, but before we get started, let's get to know each other. My name is Alexey, and for the last 8 years, I've been working as an Android software engineer. I'm really passionate about platform-specific domain like Gradle, UI testing, CI/CD, and in general about developer experience. But almost 2 years ago, I joined Reddit, where I completely shifted my focus towards video industry and making its performance and stability a bit better. So if you see that any kind of videos is not playing at Reddit, there is a small chance that it's probably or maybe my fault. The second part of my life is really, it's mostly about community actually. I like to learn and share my journey publicly, including mistakes. And 3 years ago, I became an Android GT. A bit about Reddit. Reddit is a platform where users can vote, post, and comment on organized topics known as subreddits. We have about 700 Gradle modules. We're 100% Kotlin. 70% of our screens are migrated to JPEG Compose. And to deal with all of this stuff, we have almost 100 Android engineers. And videos are literally everywhere at Reddit. We have more than 20 screens, very, very different ones. For example, videos that can be scrolled vertically, videos that can be scrolled horizontally, feeds with mixed content that can be scrolled vertically, and why not? Feeds with mixed content or detailed pages that can be scrolled horizontally. And as a bonus, we also have screens where multiple videos can be played simultaneously. And what are the general challenges with videos? Performance and bandwidth, which is mostly about balancing video quality and rendering speed, because improving one usually affects another. And Reddit is used in 177 countries with widely varying bandwidth. And video should be able to play anywhere. In some cases, video playback might entirely fail due to some firmware limitation. And really often we can see some playback error on some specific device, which is also can be challenging. And I remember around 1 year ago, I had to order a particular device just to fix this issue. Yeah, of course, Reddit reimbursed me for this device. Observability and analytics, you really need to choose between having a lot of metrics that could be very informative for you, or choose, just a few metrics that only going to tell you whether, things are good or bad. And there is not really the right answer for this question. So in early 2024, we checked our TTFF, our time to the first frame. And in P95, it used to be almost 2 seconds. And we decided to do something to make it a bit better. So 2 seconds, it's a bit sad. And during this talk, what we're going to do, I'm just going to walk you through the journey. What did we do for the last 6 months and beyond to make it a bit better. And my only goal for today is just to give you something practical. Everything I'm going to be telling going to be backed up by data that we experimented, and you're basically going to see if you go this way, how better would it be. But just in case, please don't trust me. Things that's going to work very good for us may not work for you at all. So always, if you can, do some sort of A/B tests. All right, what's going on when we want to play a video? Let's review some adaptive bitrate dash playback. So the backend side, client side asks the backend side, hey, give me some video URLs, please. So then we have a, player has to download .mpd file for the dash. What is this? MPD file or manifest is actually a representation of the video that has some sort of bandwidth that is required for a certain video resolution or quality, and the same for audio. And it also can have information for text. Once it's downloaded, so we're going to download audio segment, then we're going to download the video segment based on some quality, It looks like we are all set to play the video, but no, we're going to initialize decoders on an Android device. Then we're going to decode some first segments, and after this, hopefully, if I have a good network, video is going to be able to play. So let's take a look at this part a bit deeper. What's actually happening under the hood? We're using ExoPlayer for this, and in terms of architecture, ExoPlayer has several very important components, and the first one, ExoPlayer, that is a core entity that just coordinates all of the relationships among other components. There is also media source, which is a representation of the video that is used to buffer data and memory and store it there. For example, it could be dash media source, HLS media source, or smooth streamable. It also can be progressive, just for pure MP4 playbacks. And media source has to communicate with something to download data. For example, HTTP data source. But of course, it's not always pragmatic to load data, from network if we have data in cache. So there is a cache data source. That's going to use HTTP data source only in the case of cache miss. There is also a track selector. Track selector actually responsible only for selecting proper audio, video, and text tracks, and generates track selection in general for the first segments. Then we also have renders, for example, video render, with a goal to provide device capabilities and decode video segments and then display them to a particular surface, for example, texture view or surface view. And it's pretty much the same happening with audio render and text render. And finally, from my perspective, the most interesting component is a load control. Actually, it just answers us for two questions. Should I continue buffering? And can I start video playback? And the good thing that in ExoPlayer, we can customize whatever we want and experiment. But let's try to take a look a bit more deeper. Like what's actually happening in the relationships of those components when we call player.prepare. So in the case of if we're trying to download MP4, we're going to download MP4 headers, or in case of adaptive playback, we're going to download manifest first. So then this manifest is going to be passed to track selector. And like ExoPlayer will ask, hey, track selector, do something for me, please. And track selector considers network bandwidth to do a proper track selection. But it's not really practical to select really high resolution, if we don't have those capabilities on the device. For example, if device is not supporting the particular codec, like a playback gonna be failed. So track selector asks each render for capability. Can you play this video? And if you can, it's going to generate track selection and pass it to media source. Media source, since it's empty right now, it's going to allocate some buffers, and it's going to ask load control what to do. So load control is kind of the guy in charge. And load control, since buffers are empty, so it's going to tell, please, load first segments for me to start a video playback. We don't have anything in the cache, so loading going to be started. Once we loaded first segments, that is customizable, by the way. So we actually going to pass this data to ExoPlayer, and ExoPlayer will ask renders, hey guys, I have some data for you. Do something with this. And finally, video playback going to be started. But once it's started, it actually going to be always backfilled in case of, for example, dash, right? Seamlessly, in most of the cases, once you watch the video, it's going to backfill remaining buffers to ensure that you don't have any rebuffering. So what you can do with all of this information? Let's take a look into practical cases, actually. And the first case, I would say it's a bit easy. It's about video delivery. And the best thing I think that you could do is just to implement something that doesn't require any changes from your side. So historically, at Reddit, we used to use adaptive bitrate for 100% of our video playbacks, so an HLS on iOS. And so the thing is that, with the Dash, we have to make at least 3 round trips. With HLS, it's going to be 4 round trips just to show the first segment. And if you're using not optimized protocols like HTTP1, for example, we're always going to open new connection. So yeah, and it also contributes to playback error scenarios. What did we do? We just replaced all of this with MP4. But of course, not all of the videos. We conducted different experiments with thresholds where MP4 makes sense and when it doesn't. Just to show you a bit more data, so it takes around 5 milliseconds in P90, P95 to just fetch manifests. And it looks like 5 milliseconds is not a lot, but in videos we're literally finding for every milliseconds. What is the result of just migrating adaptive playback to MP4? So we started to have less playback errors by 5%, which increased video view. And about video loading, so 30 to 40% faster for the short video playbacks, which is, most of the things you probably have. So, and what is the learning? So if your video is less than 45 seconds, MP4 going to perform efficiently. If it's more, so then use adaptive playback. And preferably for Android is probably going to be better to use Dash because it has less round trips. So next one is HTTP version. By default, if you're going to use ExoPlayer as it is, it's going to use HTTP1, which was implemented in 1996. I probably was around 2 years old at this time, so I was really happy about it. So with OK HTTP, for example, there is HTTP2 going to be used, which was implemented almost 10 years ago. And it's also possible to use HTTP3. The difference is that HTTP1 is going to be open new connection every request. HTTP2 is going to reuse already created connections, and HTTP3 replaces TCP protocol with UDP, so which is also should be way faster. There is a good article about this that if you you can read to dig a bit more deeper than this. So, talking about OK HTTP, there is no plans to support HTTP3 from the box, but you can use it actually with Cron engine and interceptors. It should not be a problem. So at Reddit, we decided to go with the Cron engine, and we currently don't use OK HTTP stack. And all it does, we basically need to create some engine. We need to pass it to Cron's data source factory. And in a case, for example, if your API more than 24, there is a new engine which calls HTTP engine. So if you don't want to connect the Cron's dependencies, so it's all going to be handled by ExoPlayer automatically. What are the results? So we didn't GA this yet, didn't roll out this yet to 100% of users, but we're seeing really good increase, really good reduction in videos in videos more than 1 second by almost 7%. So definitely do this. So it also going to give you a lot of benefits. Next one is a load control. So whenever we start in video playback, first load control we're going to be doing, it's going to be showing some blocking buffering, or the buffering that basically user 100% is going to observe. By default, it's 2.5 milliseconds. So then, once 2.5 milliseconds are loaded, playback is going to be started, but buffer is going to be backfilled by something that calls non-blocking buffering. Difference between them is that non-blocking buffering in most of the cases should not be displayed to the user. It's something that's happening on the background while video is able to play. So for blocking buffering, there are very two interesting flags. So the first one, buffer for playback, that actually takes place in the first frame, and if playback has been stopped by user. Next one is buffer for playback after buffer, which is 5 seconds by default. And it's mostly about network latency problems. So if something has happened, with network, ExoPlayer going to next time to preload 5 seconds, just to reduce rebuffering. And we also have flags for non-blocking buffering, 2 flags, really important ones. Main buffer, it's a value that always will be backfilled during the playback, while max buffer, it's a value, at which point video playback going to be entirely, video buffering going to be stopped. So what did we do with all of those flags? We conducted a lot of experiments and replaced all of those values to different ones. For example, since most of our video playbacks are shorts, we replaced buffer for playback to 1 second, buffer for playback after buffer to also 1 second, min and max buffer from 50 seconds to 20 seconds, because it doesn't make any sense for us because we have short videos. And to make it work, you also would need to set prioritize time over size thresholds to true, because by default it's false. Really important moment here. If you want to reduce rebuffering events in your cases, it's recommended to set this min and max buffer by default. That technique calls drip feeding. It's also going to preload videos, until the end. It also performs faster. What are the results? So basically, it was one of the most impactful experiments with video we ever conducted. Video load in 2 seconds reduced almost by 18%, which increased video view. Definitely do this. Also, keep it in mind. It sounds really complicated, but all it takes for you is just do something like this, set those flags to the values, and it's just going to work. So it actually took way more time to explore what is it, to experiment, rather than implement. Next one is a prefetching and a pre-warming. So when I'm talking about prefetching, is about just to download some file earlier to have a cache hit. And when I'm talking about pre-warming, is basically it's loading data to memory and decode first segments, and whenever we ask ExoPlayer to play something, our video should be played immediately. But first, we need to implement some caching. And it's also, it sounds easy, but it has a lot of pitfalls. For example, whenever you create a new instance of simple cache, it's always going to hit the disk internally, so always do this on a background thread. Simple cache may clear other cache that doesn't belong to ExoPlayer, right? So, which sounds a bit crazy, but it's even written in the documentation that if ExoPlayer gonna see some file which doesn't belong to it, it's gonna be removed. So I know some guys already experienced this. It wasn't good. So just ensure that you define the video cache folder specifically for your app. So you also should have only one instance of simple cache, otherwise you're going to be crushed. And don't forget to use eviction if needed, so just to evict videos that are no longer needed. And just in case, so if you use some sort of security features to sign video URLs to protect them, and you may end up with a situation where you have the same content and URL is different, so you always would need to take care about cache key. So, after we implemented caching, the first approach for the prefetching you can consider is lazy. How does it work? So, let's take an example. When we want to load some data from the backend side and show the screen. So, usually video is loaded. Then what do? We of course using some architecture. So to convert video, to convert everything to domain, to UI. And when UI is rendered, we actually start to check, okay, I have some posts. Do we have a next video post as a video? And if we do have, we're going to prefetch these posts. And whenever user is going to scroll for the video post, it's going to be displayed directly from the cache, and we're going to have a cache hit. So this approach was good. But it wasn't, I would say, good enough, even though we increased video loading less than 500 milliseconds and increased video views. There is a problem. And I did some traces in production. where I just measured, how long does it take to get from loaded state to displayed state. And on some devices, it could be up to 200 milliseconds. Why? Because, we are doing some stuff on a background thread to map a lot of data, to display it, and so on. So what do? We decided to prefetch, once video is loaded, all we need is just a video URL, right? Once video is loaded, we schedule prefetching, which is not blocking, it's going to be happening, on a background thread. And instead of prefetching next video, we decided to prefetch all videos in the batch to see how it's going to be. Results are way better. For example, video loading minus 2 seconds decreased by almost 5%. But we have a lot of requests, and we started to see other TTI actual increases on some detail pages, which is also not good. And now we're trying mixed approach. By mixed approach, I mean that instead of prefetching all videos, it can be a bit more pragmatic to prefetch n videos, and that n value actually we still need to find. And for example, if we do prefetch 2 videos, and we are prefetching remaining videos once we have on-rendered callback, it's gonna behave, I would say, really similar to aggressive, but TTI is not gonna be that much affected. So it's gonna be 0.5% better. So I would say which approach to choose here, it really depends on your domain, how many requests do you have, and I would say as minimum do lazy one. If you don't have a lot of HTTP requests, aggressive one going to work the best for you. And if you want to find a good trade-off, so always go with a mixed one. To do all of this stuff, there is a download manager used. And download manager basically provides a lot of opportunities to pause, resume, and remove downloads. You can prefetch based on different requirements. For example, only on good network connection. It supports parallelization and threading, and it's actually going to work even for adaptive playback, but it's not that flexible with adaptive playback. So how to deal with adaptive bitrate then? There is a download helper that's going to select a proper track for you, and it's paired with download manager, which is good, but you can't define how much data you need to download. So there is a little bit discrepancy. So it does select a proper track for you. The thing is that it doesn't allow you to define how much data you want to download. Maybe you have a video like 40 minutes, right? You definitely would not want to download the whole thing. So there is an issue about it to create an API, which is not resolved yet. But we will tell how to deal with it a bit later. Next stuff is a pre-warming, and pre-warming sounds too smart. It's basically when to call prepare. Why it's where? It's when. Okay. So and before, how it used to work. Let's assume that we have some situation where we have a lot of text posts and we have video posts that's just displayed just a little bit. So when we're going to scroll for that state and visibility like more than 50%, we used to create ExoPlayer. We used to call the prepare, and which is not really efficient. So just in case there is a lazy list, first composition can happen before the content is being displayed. So when it could be even beyond the viewport. So what did we do with this? So we just started actually to remember in the player instance and to call it within the first composition. And it actually started to be, of course, a way better. So video load in 2 seconds decreased by 14%. Definitely do this. Keep in mind that it also would not take a lot of effort. But what is the future? Because prefetching and pre-warming sounds like really similar thing. And recently, Google introduced an API for this that calls preload media source. So media source allows you to download video streams partially. You can tell it, like, download me first couple of seconds. And it's also going to decode segments in runtime, which means that whenever you're going to call ExoPlayer, video should be able to start immediately. It's really easy to use, and it's easier to control ExoPlayer instances, because you can vary this logic to find a pragmatic approach of how many ExoPlayer instances you really want to have. So we haven't tested this yet, but I believe that potentially it can replace prefetching. So it can combine prefetching and prewarming finally into one single place. Next one is a player pool. So I was looking at Tinted Traces, and did you know that it may take up to 100 milliseconds to create an ExoPlayer instance? For the human eye, like everything that's beyond 16 milliseconds is going to be visible for the 60 FPS. What did we do? We decided to reuse instances whenever we want, for example, during navigation cases and during scrolling cases. So it doesn't make sense really to create a new ExoPlayer instance always. An idea for the first approach was like this. So we have some video composable. That's whenever first composition happens, has some sort of key like URL, and we ask player pool, give me some player. And if player is going to be empty, it's going to create new instance. So, but it's also going to associate it with the current video playback, and it's going to mark its state as occupied, which means that other video playbacks would not be able, to reuse it. Once the video has been played, video player can be reused, and we're trying to tie it into 2 to 3 ExoPlayer instances as for now. Some warning. So try to avoid calling stop methods, at least for the same playback during navigation. What is the main problem with the stop method? So if you take a look into traces, method stop is going to deinitialize video decoders, audio 1 and video 1, and it takes around 41 milliseconds to initialize video decoder and 24 milliseconds to initialize audio decoder. Or of course, it can be varying based on the device, but yeah, this is also a place for optimization. Don't forget also to evict old players, so you never know whether the logic is reliable or not, so it's always good to have some sort of threshold if we reach some limits, to send some event to the backend side, so at least to know about it. An implementation, just to summarize all of this, so looks very simple. So we have a player cache, which is a hash map, and for the best case scenario, we're just going to return the player. So if we're not going to have any player, we'll find the first player, which is idle, which can be reused, and only in this particular case, so we're going to change player owner from previous URL to a new URL, and we're going to call stop here. And stop here is unfortunately required because it may be the case that first segments of already displayed videos is going to be leaked into the new video playback. And in the worst case scenario, we're still creating the player. What is the result of this approach? So load 2 seconds or rendering 2 seconds decreased by 2%, which increased also watch time by 7%. But not only that, so we have some metric that calls number of frozen frames, or just like child of INR. INR is a 5 seconds, if I'm not mistaken. So we have also control of how many frames do we have that's rendered under 700 milliseconds, more than 700 milliseconds. So, and we reduced the count of those frames by 2%. So definitely do this. But can we actually do better with this? And the thing is, we can. So in the second iteration, we decided to initialize players on application start with a startup library. And we also decided to do it on the background thread. And it's in non-blocking ways, which means that it's not going to block the application starts. We're just going to schedule it on the background, and whenever first video composable going to ask for the player to play a pool, we're always going to have at least a couple of instances that can be easily reused. Just in case, don't forget to handle multi-threading here, so with locks and double-check buttons. That could be really reliable here, because you never know how fast applications start on your particular device. We improved only 3 video playbacks, first couple of video playbacks, and we're already seeing really good improvement in terms of loading under 250 milliseconds. But we also decreased number of frames that takes longer than 16 milliseconds, so which means that the application works a bit faster. So definitely do this. The next thing is a view pool. So with videos, unfortunately, we still have to use texture view or the surface view. Of course, we have some kind of composable function for the surface, but under the hood, it's still going to be old-fashioned surface view. We measured it, and we realized that it may take around 30 milliseconds to inflate the video, which is also a lot. And it looks like the potential solution could be something like this. Android View has some callbacks on result that's going to be called before view is about to be reused, and on release, that's going to be called when video is not going to be reused at all. But it doesn't work actually as good as we really want. And the reason is why it doesn't, because it works good only for the same view types. So if you have a single view type in the list, like videos, it's going to work great. But if you have sort of mixed content, you're still going to create video views, and some of the playbacks are not going to be really efficient. So, on release, in this case, going to be called really often. So, we also can't control really instances count with this approach. That we also may want to do. And we are all living in a world where we don't even discuss whether we're going to have single activity application or not, like it was 10 years ago, right? Currently, nothing stops us to pre-initialize those views in some sort of main activity, for example, right? And just reuse them once the particular screen is loaded. So what did we do? We implemented our own view pool, old-fashioned one. So where we have view cache and just 2 methods. So the first one going to, in the best case scenario, is going to return already stored video view. And if we don't have anything in cache, we're going to create one, which is fine. But it could be better. And in the release methods, we're just going to return the view to the cache and do some eviction if requires. And we do provide all of those views with composition local. And integration, it's a bit tricky. So you only would need to implement factory with acquire methods and only on-release methods. And that's it. And no more, I would say, because, for example, if you're going to use on-release with on-reset, you will end up having multiple view pools, your one and Android one, which is a system one. So, and also, if you have to store video, like an old-fashioned view instance somewhere to handle some states, which you better not be doing, so ensure that you handle all of the releasing process and on-release method, because Android View on-release called way later than on-dispose or in the root composable function. And also, ExoPlayer has video controls in place. That's really easy to implement and so on, but always implement your own controls. Because if you're going to take a look inside, those video controls, they do inflate a lot of stuff, like captions, for example, right? Maybe you don't even need to render this. It's also going to affect your TTI. So, and always implement your own controls. With all of this, we started to see a huge boost in videos that are loaded less than 1 second. Do this, please. So next question is a surface view and a texture view. Just in case, whenever you need to, to build some classic screen, internally under the hood, there is an activity, and the activity actually has its own window. So this window always going to be synchronized with GPU, which sounds crazy, but it's actually, yeah, this is how most of the screens are working. To address this problem, Google introduced Surface View. And in documentation, it's basically what it's going to do. It's going to remove that caching layer, and you're going to draw your content directly to GPU, which sounds impressive. And in documentation, there is actually mentioned that you can use texture view for scaling, rotation, alpha, and it's really simple to use. But it's not that efficient in terms of performance, battery consumption, and it has lack of DRAM support, which may be an issue. Surface View, though, going to work good in terms of performance, DRAM support, but it's actually complex to use in some cases if you have a lot of animations. And it doesn't support some sort of animations even still. We decided to give it a try, see how it's going to go. And the first problem we started to see is an overscroll issue. So basically, whenever you want to scroll beyond the video, we just started to see like sort of white frame. So we spent a couple of days, and it turned out that we just copy-paste some old code with layer type attribute that affected this behavior. So nobody knew what this attribute does. So be careful with this. And you also might have some problems with animations. And for example, here is two animations with absolutely the same code. Left one is a texture view that works as expected, and the right one is a surface view that it actually has some issues. So TLDR, after we started to see performance data, it didn't really work well for us. And all of the results are actually neutral. Load time, TTFI was neutral for us, frame metrics neutral, even battery metrics was neutral because it's only possible to write battery performance tests on the modern device, which is kind of maybe doesn't make sense. So only use it if you optimized 100% of things, because the chance that it's going to slow you down during the development is actually really high. But I still do believe that Surface View are going to improve some performance on lower-end devices, so don't completely abandon to this idea. So we implemented all of this stuff. 6 months later, things started to be way better in terms of P95 first frame rendering, like 30%. We were really excited about it. I even decided to submit this talk. But 1 month later, we started actually to have some spike. We just started, to be worse for around 200 milliseconds. And again, we are fighting for every millisecond. This is like really bad feelings. So, and I'm telling you, all of that, if you wish to optimize things, the first thing you really need to do is implement performance metrics that are going to work reliably for you, not only to display TTFF time or TTI. So some of the ideas how it could work. You may have rendering time, and whenever we render video, there is view creation. It could be 30 milliseconds. Then it's player creation. It can be 100 milliseconds. Loading, which depends really, and decoding. So that's to initialize instances only may take up to 64 milliseconds. So we implemented some stuff that will allow to monitor it. So it's actually available for this QR code. But talking about conclusions, all of the optimizations that we are doing, in most of the cases, the first question you should ask, potentially should ask, can I remove this operation? Should I even play videos in those cases or not? And maybe you shouldn't. Second one, if you have some operation on UI thread, it looks like I can move it to IO thread and it's going to work fast, but not really. So you really should have a great reason, to move things on a IO thread, because It may take around at least 16 milliseconds to switch the context from the UI to the background one, so always be careful with this. If you can initialize something earlier, like preheating and pre-warming, so it's going to give you a lot of benefits. Caching and reusability, of course, in this case. And on the last point is about making it faster. And those things like, for example, modern video codecs or versions of HTTP protocol or optimizations on the video encoder side where we can basically improve bidirectional frames when our video is being encoded just to reduce this time. It's only the last thing from my perspective. And the most important one, it requires just a lot of patience. Things that's actually what I told you right now. None of the things worked with the first attempt and required some follow-up. But I tried to show you the best case that definitely going to work. Here are some links from this talk that's actually, unfortunately, beyond of time. So a couple of good articles from Pinterest where you can improve your playback even further. And thank you.